Single Pair Ethernet. SPE is an exciting new transmission technology that will influence the building and industrial automation in the coming years. This presentation will deal mainly with the role SPE can play in relation with all IP smart buildings. SPE is an addition to the existing digital ceiling concept and will supplement and not replace RJ45 installations in this environment. SPE does not stand for its own. It is a result of the history how the application evolved. It all starts with the known structured cabling system. The generic cabling system runs from the workspace up to the floor distributor and connects people to the internet. It provides, so to say, the internet of people. The big change to this setup happened when Power over Ethernet provided the possibility to give remote power via the same cable as data. And only one cable is now necessary to completely supply a device with data and power. With this, new devices came into focus, most notably IP cameras and wireless access points. These devices are part of the building infrastructure and not anymore strictly part of the IT. Of course, the introduction of PoE added a bunch of new requirements to the generic cabling system. These requirements are discussed in several publications from R&M. See for this the 4-pair Ethernet and the PowerSafe white papers. These first infrastructure devices whet the appetite and opened the door for much more building automation devices to be connected to the LAN. The standardization committees reacted to this demand by the creation of the ISO IEC 11801-6 standard. This standard specifies a structured cabling in the ceiling with a service outlet SO covering a predefined zone for all IP connection needs, the digital ceiling. All the devices in this zone connect to the nearest service outlet and from there to the nearest floor distributor and are connected to the network there. Here is where the IEEE concept of the single pair Ethernet fits in. If in the future so many devices have to be connected to the internet, the fear is that RJ45 connections are too bulky to provide the necessary connection density. As a solution to that, single pair Ethernet has been introduced to this field of application. It roughly doubles the capacity of network devices and potentially reduce the cost of connections, because as the name says, it's only one pair instead of 4. As you can see on this picture, on this study really, you see that it's roughly a doubling of the port density is possible with single pair Ethernet. However, as we can see here, the service outlet still remains to be an RJ45 because for the high bandwidth applications like the wireless access points or distributed antenna system, where a 4-pair transmission is still needed. Single pair Ethernet was originally designed for automotive application. We can still see that in the specification of the 100 megabit and 1000 megabit variants with reaches of 15 or 40 meters for unshielded or shielded This obviously is enough for a car, but would not reach anywhere near in the building environment. For building automation and industrial automation, IEEE defined the 10BASE-T1, 10 megabit transmission speed for distances up to 1 kilometer. However, these are two different variants of the 10BASE-T1. It's the L long version that reaches the mentioned 1 kilometer, but there's also the short version S, which allows to have multi-drop capability. More to that later on. We also see further developments going on in IEEE on the automotive side with multi-gigabit single pair Ethernet developments, but here again for cars, and these are for autonomous driving applications where they obviously need a very high bandwidth within the car. The POODLE, the power over data line, is the SPE version of PoE. It provides power over the same line as the data, and its most powerful version, the class 15, it is able to deliver up to 52 watts with a DC voltage of 50 volts. POODLE defines different power levels, 1 to 15, with different voltages and different power levels. With the 10BASE-T1L, the distance is often referred to as the 1000-meter protocol. However, it's important to recognize that this is only valid for data transmission only, without POODLE power supply. We see this in this first column with no power, and we can actually reach up to 1000 meter transmission distance with a wire gauge 18 cable, or around 629 meters with a wire gauge 22 cables. However, if a POODLE class 15 power transmission would be applied, these distances drop dramatically. With a 50 watt transmission, we would only be able, with a wire gauge 18 cable, to reach about 170 meters, and with a wire gauge 22 cable, we are actually below the 100 meter threshold of the structured cabling, and would actually be only able to support up to 70 meters. So if we are looking for cabling in the building environment, we would have to restrict the POODLE class to 14, so only able to support 20 watts to one device. The single pair Ethernet standardization works in different standardization bodies. The responsibilities within these different committees are clearly defined, and we see it mentioned here. This prevents duplication of work, but of course coordination and interaction between the standardization bodies is rather difficult and time-consuming. So IEEE defines the requirements of the channel. ISO ISC or TIA or CENELEC take on that requirements and specify the channel requirements out of that. And based on the cabling modules, they also define the requirements for the individual components. The ISC committees for cabling or for cables or for connectors, for example, take these requirements then and provide a specification for the components. To coordinate the whole thing, there are different user groups and associations that look for it, that the whole thing works together and at the end can be used as a system. Within the connector standardization, we have 6 different connectors that are standardized for single pair Ethernet. However, at the moment we have no decision on which connector type has to be used in what use case. We do see that ISO ISC and TIA made some connector decisions for MICE 1 and MICE 2 or 3 outlets, which are the -1 or the -6 connectors. However, these recommendations are for the outlet only, and at the moment it's quite unclear in what use cases an outlet really would be needed. So the whole decision is not clear whether we really have something meaningful here. The general consensus seems to be that the connector should be selected that best suits the environment conditions of a specific use case. And definitely the standardization groups missed to define one common interface because they actually decided to promote with the -1 and the -6 two incompatible solutions for the industrial environment here and for the building automation environment. The easiest way to integrate single pair Ethernet into an existing digital ceiling is to place a single pair Ethernet zone switch near the service outlet. Based on the defined zone size, every single pair Ethernet protocol that we have seen would be able to support the complete range of the zone, and all poodle classes could be applied in these structures. So this solution is a pure plug-and-play solution that could be realized immediately if you have a digital ceiling concept. However, the 10BASE-T1L protocol also would allow the use of existing RJ45 cabling of shielded Cat6 or above to transmit 4 times one single pair Ethernet channel. In this case, the single pair Ethernet switch could be placed in the floor distributor in a centralized place, as we know it today. In this case, however, as we have seen, Poodle would restrict the class 14, 20 watts, due to the length restrictions we have of 100 meters and cable diameters of about 24, wire gauge 24 or 22. However, digital ceiling still is not the most commonly used implementation in the building automation. On-demand cabling is normally used in this environment. And in this regard, single pair Ethernet probably would most commonly be used in on-demand cabling, meaning the devices will be placed where they have to be within an area, and then they would be connected to a nearest sub-distribution point, or if a centralized solution is required, they could be connected to the nearest floor distributor with single pair Ethernet cabling. In this case here, we probably would need single pair Ethernet panels in the floor distributor and 19-inch versions of the T1 switch. With a wire gauge 18 cable to be used in here, we could actually reach distances of up to 160 meters, which should be rather okay, even with a class 15 poodle applied here. The multi-drop technology is introduced to single pair Ethernet in order to minimize the use of cable. Multi-drop means that more than one device, so multiple devices up to 8, can be connected to the same cable and communicate with each other. The way to do that, according to IEEE, is the use of T-junction connection. So basically what we have is a trunk cable that runs from one device to the other, that is installed where it's needed, and on this trunk cable you can attach up to 8 individual devices with a T-junction connector. The restriction in here is the length of this so-called stub with 10 centimeters length. This restricts the usability of this solution quite a bit. So basically you have to know where your devices are when you lay in the cable in order to be able to actually go with the trunk cable very near to the area where your device would be at the end. A much more flexible way to do that would be the use of a daisy chain implementation. And the special idea here is to use duplex connections. So if in a duplex connection, the two sides of the jack are connected together, so if you implement a small T inside the device, you would be able to add one device after the other, and you would always maintain the integrity of this 10 centimeter stub, because you have it on one PCB basically in here. So you have a stub of whatever, a few millimeter length. The standardization for multi-drop has just started yet. So there is no guidance from standardization committees yet. And the discussion is in full swing on how best to implement and standardize the cabling for this multi-drop application. We have seen before that the consortiums have an important role because they bring together different companies and make sure that all these different committees are staying aligned. The first single pair Ethernet consortium that was founded was the TIA spec. So this is a consortium, single pair Ethernet consortium, that operates under the umbrella of TIA, and basically brings together, let's call it cabling companies. So companies that are interested in the cabling of single pair Ethernet working together, R&M is part of it. Mainly spec is US based, let's call it. It's strongly driven by connectivity, on the connectivity view, and it focuses on building automation. In Europe, we have a different consortium that was formed, the Single Pair Ethernet System Alliance, where Arnhem was a founding member of this consortium. This is a consortium that focuses more on the overall single pair Ethernet technology. So it brings together companies from all parts of the channel. So we have chip manufacturers in here, we have sensor manufacturers, connectivity manufacturers, of course, as well. So this is a much broader approach to the single pair Ethernet technology. The Single Pair Ethernet System Alliance is mostly Europe-based with some Asian companies coming in. At the moment, about 30 companies that are in that group and working together to promote the Single Pair Ethernet technology together in the market. The Single Pair Ethernet interface selection is not defined by standard committees, or at least the standard committee selected two different designs, the Type 1 and the Type 6, for the outlet of the different applications, so one for industrial Ethernet and the other one for building automation. Unfortunately, they actually missed to harmonize here. So that is based in the standardization that they actually came up with two different designs. And obviously, having missed to harmonize on one design, there is no reason really to stop there. So especially on the industrial Ethernet side, there is some unsatisfaction with the chosen T1 connector from Harting because of its size. The problem with this design is that it is too big to fit into a standard M8 housing, which is very important industrial environment. And that is the reason why, for example, the System Alliance choose to promote the -5 and the -2 variants here, what we call the MSP. This is a much smaller design, which actually fits in every M8 housing, and therefore gives a better usability in this environment. Now, on the building automation side, typically we did have a much more, let's call it, standard following policy, and therefore the LC copper, the -1 solution is very much set. However, also in building automation, very, very often the switches that are used in this environment, they are coming from the industrial Ethernet side. And in the System Alliance, we will have within this year industrial Ethernet switches with the MSP design. And it is very well possible that these active components will also migrate into the building automation side. So on building automation, we still see the chance that either the -1 or the -2 would be used in the future. That is the reason why R&M decided to leave its customers the freedom of choice in the connected design. For people who want to follow the standard committee's recommendation in the building automation, R&M offers the IC 63171-1 version, the LC copper version, and for people who would prefer a more compact design, go with industrial style connections. We also offer the IC 63171-2 design that we call the MSP, the multi-purpose single pair plug. So both products will be available from R&M. And for R&M, it was important that we are offering a complete channel. So we are not just aiming for one specific product. We do have the complete channel with installation cable, connection modules that are able to connect two installation cables, so two lines with a duplex plug, and we have the patch cords fitting to it. All these products, they use IDC termination technology, proven a million times in the RJ45 environment. They are of proven, robust design, and the connection modules, they do have this adapter plate, freenet adapter plate, that allows them to connect to every freenet platform, panel, or outlet that we have in our assortment. With this, we do offer a complete channel to the market, including all the requirements or all the additional products that need to be there to really be able to use the products. Now, these products, they will be commercially available or available in commercial quantities in the fourth quarter of 2021. In order to be a little bit earlier on the market, we created a single pair Ethernet evaluation kit. This evaluation kit will be available from June, mid of June onward. However, due to the fact that the products inside have been produced with prototype tools, they are only available in limited numbers. There will be 3 different evaluation kits available. So one with LC copper only, so with 2 LC copper connection modules, 2 patch cords, and an installation cable of 10 meters. Or same with MSP, 2 of the same connections, 2 of the same patch cords. Or we also have it in a mixed version where we have 1 connection for LC and 1 for MSP each, in order to be able to compare the 2 sides of the channel. So basically, this evaluation kit is intended for business development and for partnership build-up. Also, the product development for single pair Ethernet at R&M does not stop with these mentioned products. Already, additional products are in the development pipeline, with a product launch that is planned for 2022. So notably, we have two products here that already have been patented. So one of them is a microsplitter design where 4 single pair Ethernet connections would come together and could use one RJ45. So each pair of the RJ45 is spread out into 4 individual cavities here, and the patch cords can be attached in here. So this is for splitting application use of existing RJ45 cabling, or even of existing, in the future, of existing switches that may be able to recognize whether a base T or a base T1 application is plugged in. And the other product that is already designed to do, where we are working on, is a field terminable version of it, which should have the ability to integrate legacy field bus cables. Here, definitely, we need additional input from the application side, how this termination should be specified, but already we are in the first development steps there. So based on the motto that we provide the connectivity that matters, R&M is your partner for end-to-end single pair Ethernet connectivity. And visit our website with the link mentioned here, where we have much more information available on single pair Ethernet, but also on digital sealing implementations and power over Ethernet. Thank you very much for listening.